Welcome to BTEC Revision. In today's lesson, we're looking at the sine rule. By the end, we will be able to calculate the lengths or angles of a non-right-angled triangle using the sine rule. What is the sine rule and when do we use it? The sine rule is a rule that we can use to calculate the angles or lengths of any triangle. For example, if I wanted to calculate the length A, then I would need either B and sine B or C and sine C alongside sine of A. For example, let's take A to be equal to 10, and we'll take the angle capital A equal to 30 degrees. Then we can take B to be equal to 15, and we'll take capital B here to be equal to 20 degrees. Now we can use the equation where we take A divided by sine A is equal to B divided by sine B. We can rearrange this equation to make A the subject, so that's A equals B divided by sine B times sine A. Now we can just plug in our values. So we have B is equal to 15 units divided by sine B. So sine B is going to be the angle opposite the length, so that's sine 20 degrees, multiplied by sine A, which is 30 degrees. I get 21.9 units to three significant figures. So you can see here, if you want to work out the length, you would need the opposite angle, and you would need another angle and its opposite length. We also have a second version of this equation. So we can see this is the reciprocal, and we get sine A at the top. This is what we can use in order to work out the angle. For example, let's take capital A to be the question, and lowercase a is going to be 10 centimeters, capital B is 30 degrees, and lowercase b is 15 centimeters. To work out sine A, we would rearrange the equation, so that would make sine A is equal to A. Now here we got the B values, so that's going to be sine capital B divided by B. A equals 10 centimeters, sine B, which is 30 degrees, divided by 15 centimeters. To calculate A, we'll take the inverse sine, and that will give us A is equal to inverse sine of 1 over 3. And this gives us a value of 19.5 degrees to three significant figures. The sine rule can be used for any angled triangle. So we can use it for the triangle on the left and the right. However, for the triangle on the right, we can see we have a right angle, and only for right angle triangles can we use SOHCAHTOA. So this is the only triangle we can use SOHCAHTOA for. We cannot use that for the triangle on the left. We'll learn more about Pythagoras, and for Pythagoras' theorem, we can only use right-angled triangles, so not the triangle on the left. Now let's look at an example. Here we have a question to calculate the length A. Pause the video here and attempt the question. In this case, we're asking for A, so we'll have the formula with the A on top first, divided by sine capital A, and that's going to be equal to B divided by sine capital B. Now it doesn't matter, we can write is equal to C divided by sine C. We can take the angle to be either B or C. It doesn't matter which way we choose them. But the most important thing is, if we have one side, A, for example, the opposite side has to be the angle A, like so. And for example, let's take the angle pi over 4 to be capital B, the angle. That means the opposite length has to be the length b, lowercase. Now we can rearrange the equation for a, so that gives us a equals sine a times b over sine b. Plugging in our values, we get sine a is 1 radian times b, which is 1.2, divided by sine I over 4 radians. Now, very important to note here is that we have to change our calculator units to radians. Calculating that, we get a value of 1.43 to 3 significant figures. Now pause the video here and attempt this exam question. Let's start by setting our values. We'll set the angle to be capital A, and the length opposite is little a, and then we'll set the angle 30 degrees to be capital B, and the length opposite to be lowercase b. Now we can use our equation. So it says calculate the angle, so we'll start with using the equation sine A divided by little a is equal to sine B divided by little b. Rearranging sine A, we have A sine B divided by B. Now we can plug in our values. You know, A is 10 millimeters. Now, if you note here, we've got millimeters for A and centimeters for B. So it would make a lot of sense to convert these units to the same unit. We'll convert it to meters. So we know that 10 millimeters is actually 10 times 10 to the power of negative 3. And then we can times sine B, and we know that's 30 degrees. So we're using degrees. So make sure your calculator is set to degrees, and then we divide by B, and that's going to be 8 centimeters. So centi is 10 to the power of negative 2. And we get a value of 1 over 16. So taking the inverse, that would give us A equals inverse sine of 1 divided by 16. And that's equal to 3.58 degrees. And that's the end of the lesson. If you would like to boost your grades, visit us at btecrevision.com. See you next lesson.